Now I'll be doing the probabilities under the condition of statistical dependence. We have already talked about the statistical dependence, which means when the probability of some event is dependent or is affected by the occurrence of some other event. So statistical dependence is something when the probability of some event is dependent by the dependent or affected by the occurrence of some other event. Now in this case I will be also talking about the marginal probability, and I'll be talking about the joint probability, and I'll be talking about the conditional probability. However, I will be discussing them in the reverse order. First I will be talking about the conditional probability, then I will be talking about the joint probability, and then I will be talking about the marginal probability in this case. Now the conditional probability under the statistical dependence, and joint probability under statistical dependence, and marginal probability under statistical dependence. Now let me take up the first one, that is conditional probability under the conditions of statistical dependence. Now let us to understand this conditional probability, let us take an example. Say for example I have a box that contains 10 balls. Now these balls are distributed as 3 balls, 3 are colored, and dotted. Now one is colored and stripped, and I have 2 are grey and dotted, and then I have 4, 3, 4, 5, 6, yes, I have 4 left. 4 are grey and stripped. Now I am given these 10 balls and they are distributed as follows: 3 are colored and dotted, 1 is colored and stripped, 2 are grey and dotted, and 4 are grey and stripped. Now suppose now I'm being asked that I've been asked a question that what is the probability that a colored ball drawn at random is dotted. In the first case, and I've been also asked what is the probability that this ball is stripped. Now I have been asked 2 questions: colored, what is the probability if I draw a ball and that it is dotted and it is stripped. Now I'll be talking about this condition over here. Now firstly let me talk about what is the probability of each of the ball. Now I have 10 balls So my events are going to be 10 in this case. 1 2 3 4 5 6 7 8 9, and let me write one more, and I am going to have one more, that is 10. Now since there are 10 balls, so each of the event will have the probability of 10%. So it will be 0 0.1, 0 0.1, 0 0.1, 0 0.1, 0 0.1, 0 0.1, 0 0.1, 0 0.1, 0 0.1, and 0 0.1. Now I know that 3 are colored and dotted, so let me say that we change the color over here. So now the 3 balls over here are colored and dotted. Then I have one colored and stripped. Then say for example this ball over here is colored and stripped. Then I have two more, they are gray and dotted. And then I have 4 left, they are gray and stripped. Now let me move on to the question, that is, what is the probability that I draw a colored ball, it is dotted. Now the first case where I say that the probability that I have the dotted ball that is already colored, because I'm drawing a colored ball, and it has to be what is the probability of getting a dotted ball given it is colored. So now in this case how I can calculate this, because this is a conditional probability where given the dotted ball has to be selected among the colored balls, so I have to take only the colored balls. I have to calculate the probability of only the dotted balls given they are the colored. Now let me say that in this case how I will get it. Now this will be given by the probability of dotted and colored balls divided by the probability of colored balls. Now how many dotted and colored balls do I have over here? Dotted and colored, if I look over here, the dotted and colored balls are 3, and the total colored balls, there are 3 and 1 over here, 3 in this case and 1 over here. So I have a total of 4 balls that are colored. So in this case the probability will be equal to 0.7. So this is equal to 0.75. Now the second question that this question is asking is that the probability that getting a stripped ball given it is already colored. So I have to calculate the probability of the stripped ball given it is colored. So in this case it will be the probability of stripped and colored balls divided by the probability of colored ball. Now let me look over here. Stripped and colored is just 1, and the colored balls are 3 and 1, that is 4. So this will be equal to 1 by 4, which is equal to 0.25. So this is the way how we actually calculate the conditional probability under the condition of statistical dependence. So now let me say like this: probability of event B given that event A has already occurred will be equal to probability of B, A occurring together divided by probability of event A. So this is presented as follows: probability of event B occurring given that event A has already occurred. Now this is the probability of B and A occurring together. Now this is simply the probability of A. So this is the way how we actually calculate the conditional probability. Now let me take one more case over here. Say for example I'm given the probability of the dotted ball given it is gray. The probability of dotted ball given it is gray, it will be calculated as probability of dotted and gray ball occurring together divided by probability of gray ball. So dotted and gray, if I look over here, the dotted and gray are two balls. So these are two balls, and the gray are 1 2 3 4 5 and 6 balls. So 2 by 6 is the probability of dotted and gray, which is going to be equal to 1 by 3. 1 by 3. So if I be asked to calculate the probability of the stripped ball given it is gray, now I will be looking for the probability of occurrence of stripped and gray together divided by probability of gray. Now in stripped and gray together are here, so they are 1 2 3 and 4 balls divided by probability of gray. So I have the 6 balls that are equal to gray, so it is going to be 2 by 3. This is the way how we actually calculate the probability under the condition of the statistical dependence. Now let me move on to the calculation of the joint probability. So joint probability under the condition of the statistical dependence. I have already talked about that the conditional probability, or that is probability of event B given that event A has already occurred, is that probability of B and A occurring together divided by the probability of event A. Now in this case, this probability of B and A occurring together is the joint probability. Now joint probability, so I need to solve for this, the probability of B and A occurring together, which will be simply given by cross multiplying them. That is probability of B given that A has already occurred multiplied by the probability of A. This is how we actually calculate the joint probability under the condition of the statistical dependence. Now let me take, say for example, let me calculate from the same using the same example as we have used in the while the calculation of the conditional probabilities, where I have 3 balls, they are colored and dotted, where I have 1 ball that is colored and stripped, where I have 2 balls that are gray and dotted, and I have 4 balls that are gray and stripped. Now in this case, what I want to calculate, I want to calculate the probability of colored and stripped ball. Colored and stripped. So a colored and stripped ball, it will be given by probability of colored given that it is stripped multiplied by the probability of stripped ball. Now the probability of colored given that it is stripped, and it is equal to, how would I calculate it? Now I've already calculated previously. Now let me do it over here again. The probability of colored given that it is stripped will be calculated as probability of colored and stripped occurring together divided by the probability of stripped. Now probability of colored and stripped occurring together is equal to 1 divided by probability of stripped. So how many stripped balls I have? I have 1 over here and I have 4 over here, so this is equal to 5. So in this case the probability is going to be equal to 0.2. Now what is the probability of stripped? So in this case, how many stripped balls I have? I have the 1 over here and I have 4 over here, so I have 5 stripped balls. So which means that the probability of stripped balls is going to be equal to 0.5, and this is going to be 0.2, and in this way I am going to calculate the probability of colored and stripped ball occurring together, which is going to be 0.1. I can calculate many other probabilities from the same example. Say for example, if I want to calculate say for example I want to calculate the probability of a gray and dotted ball occurring together. Now in this case it will be calculated as probability of gray given that it is dotted multiplied by the probability of dotted. Now let me solve for this. Probability of gray given that it is dotted will be given by probability of gray and dotted occurring together divided by the probability of dotted ball. Now gray and dotted are here. There are gray and dotted are 2 balls, and the total dotted balls are 2 here and there are 3 here. 1 2 3 4 and 5. So 2 by 5, which is equal to 0.4, and the dotted balls I have 3 over here and 2 over here. There are 5 balls, so which means their probability is equal to 0.5 into 0.4. In this case it is going to be equal to 0.2. In this way we calculate the joint probabilities under the condition of statistical dependence. Now let me move on to the last one, that is the marginal probability under the condition of the statistical dependence. Now marginal probability under the condition of statistical dependence. Now marginal probability under the condition of statistical dependence is calculated by summing up the probability summing up the probabilities of all the joint events in which the simple event occurs. Now summing up the probabilities of all the joint events in which the simple event occurs. Now let me explain the marginal probability with the help of an example, using the same example as we have used in case of the conditional and the joint probability. Suppose I want to calculate the probability of colored ball. So I have to sum up the joint probability in which this simple event occurs. So now let me see where this colored ball is. The colored ball is occurring with dotted ball, and it is occurring with the stripped ball. So in this case I need to calculate the probability of colored and dotted ball plus the probability of colored and stripped ball. In this way I will be able to calculate the joint probability, the marginal probability of the colored balls. The colored and dotted are 3 balls, so the probability is equal to 3. The colored and stripped is equal to 1, therefore the probability is going to be equal to 0.4. Now suppose I need to calculate the probability of a gray ball. Let me see, gray occurs with dotted and gray occurs with stripped. So which means that I need to first find the probability of gray and dotted together plus the probability of gray and stripped together. Now gray and dotted are 2, which means the probability is going to be 0.2, plus they are 4, which means the probability is going to be 0.4. So the total is going to be 0.6. In this way we calculate the probability of the marginal probability under the conditions of the statistical dependence. Now lastly I can summarize all what we have learned under the condition of statistical dependence, but let me first wrap this. Now let me summarize all the formulas and symbols that we learned under the conditions of statistical dependence. So now let me write it up for you. So in this case we're going to summarize all the things together. Now let me write it up. Now the first one, the type of probability. So the first one is marginal probability, the second one is joint, and the third one is conditional. Now how do I actually calculate them? The formula are going to be like this, or let me first write down the symbol. So it can be simply the probability of the probability of AB, or the probability of BA, does not matter. Then probability of A or B given that A has occurred, or probability of A given that B has occurred. So we can calculate it like this. Now the formula is going to be somehow like this. So in the case of the marginal probability, it is going to be the sum of, I've already written it, the sum of the probabilities of the joint events in which a simple event, over here the simple event is A, in which A occurs. Now the joint probability, when I have probability of the A and B occurring together, so in this case it is going to be probability of A given that B has already occurred multiplied by probability of B. Now in the case of BA, it's going to be probability of B given that A has already occurred multiplied by the probability of A. Now over here, probability of B given that A has already occurred, it is going to be equal to probability of BA occurring together divided by the probability of A. Now probability of A given that B has occurred, it will be given by probability of A and B occurring together divided by probability of B. So this is all about the probabilities under the condition of statistical dependence.